Fantastic. Hello and welcome back. It's great to be here with all of you. I really enjoy being out with you here in Miami and talking about quantum computing and with all the thousands of you who are watching online. For those of you who have just joined us, my name is Murray Tom. I'm the Vice President of Product Management at D-Wave Systems. And I've actually, just this last year, celebrated my 20th anniversary with the company. So I've actually been working at D-Wave for 20 years, which has been really exciting. I'm going to be giving an update on our Leap Quantum Cloud Service and our open source Ocean tools and talk to you about the latest technology that we have available in those systems. There we go. So we're going to begin with the Clarity Roadmap. This was announced in September of 2021. And as a 3-year roadmap, it helps to give us a bit of a guide of where we've been and where we're headed so that we can really understand where we are today. So I'm going to be talking through, in this talk, a set of technologies. I'm going to be talking about updates with our CQM and our hybrid solvers. I'm going to be talking about the Advantage 2 prototype that's in Leap that Mark and Emil also talked about. I'm going to be talking about our gate model programming and our Ocean tools, as well as the expansion of in-region systems in Leap worldwide. And that's going to kind of bring us through the technology updates from the last Qubits conference to this one. And that's going to allow us to look ahead at where we're going, where really what we're doing here is we're going to be doing advanced product updates along those same lines, pushing the boundaries in order to align with focused and effective training programs that allow small professional teams in your organizations to produce high-value features in their production applications, and in so doing, delivering tremendous business value to your organizations. Now, the CQM solver, it's part of our hybrid solver service suite, and hybrid solvers are combining quantum and classical compute in a workflow that's helping to bring you business value today. Hybrid is really about recognizing that no computer that will ever be built will ever be large enough to handle your full application scale problem. And you might ask, why would I say that with such confidence? Because classical computers have been built for 70 years, and they're not large enough to ingest your full application scale problems. So really, it's about taking large-scale problems and applying multiple strategies to them and breaking pieces out in order to be able to get high-quality solutions. The second thing that hybrid recognizes is that both quantum and classical technologies have complementary roles to play in the service of resolving full-scale application problems in production. So what have we done with our CQM solvers? Well, first, their capability is to allow you to represent discrete variables. I'm talking about binary variables and integer variables. This is particularly important when you're thinking about tasks where you're assigning resources to problems, for instance. But in addition to that, many real-world problems involve real or continuous variables. So for instance, in the bin packing problem that Nitish Umang was talking about earlier for Johnson & Johnson, being able to represent the position of the boxes in three-dimensional space requires those continuous variables. Beyond just the variable representation of your problem are constraints. So these solvers handle up to 100,000 constraints, and that's important because that's a key part of applications. It's sort of the weight limits and the budgets that we're considering as we're doing these optimizations in different tasks. And importantly, the CQM solver now has the ability to handle weighted constraints. So for the programmers on your team who are developing formulations with these solvers, that allows them to prioritize the relative consideration of soft constraints when solving the problems. And being able to soften constraints and prioritize them allows you to relax back some of your business requirements in order to be able to get an operational solution in a reasonable period of time. In addition to those weighted constraints, we've also introduced pre-solve techniques. A pre-solve technique is a set of algorithms which reduces an incoming problem without changing it. And this allows you to make the problem smaller and faster for the hybrid solving technology to approach. All of these technological updates in the CQM solver combined are going to allow your teams to be able to reach to larger application instances to get to those really challenging problems that are going to allow you to push your business in the directions that you want to go. And it's going to allow you to reach better quality solutions in those larger instances that you're targeting. All right, so Mark and Emil talked to you a lot about the next generation Advantage 2 quantum processors that we're working on. And I'm here to talk to you about the prototype of that system that's available in the cloud. Now, as Emil said, the prototype has a subset of the innovations that the Advantage2 system, the full-scale 7,000 qubit system, will have when it comes online. But importantly, this system has 563 qubits, so it's larger than our full-scale second-generation quantum processor, the D-Wave 2, and it has the 20-way interconnectivity. So the reason that we brought this available in Leap the moment that it was available for problem solving is because this gives your teams who are following processor development closely the opportunity to dive in, explore that new architecture, and begin to give us feedback. Because your feedback about our quantum processor development is really important in terms of like tuning the direction that we're taking. In addition to that, for people who are developing hybrid quantum classical algorithms, being able to interface with this system gives them insights into the directions that our quantum processors are going. Now, there are two really key observations I want to make with the delivery of this system here and its higher connectivity. The first is that unlike the trend in the industry, where people are reducing the connectivity in their quantum processors, in order to be able to maximize their rating in some abstract metric, we're measuring ourselves based on the business value that we're able to bring you in your real production workflows. And that has taught us that the role for the quantum processor and the hybrid workflows I just talked to you about, in order for it to play its best role there and have the highest impact on your production applications, it needs to have higher connectivity. So it's by focusing on the results for practical quantum computer that are going to be delivered to you in application, we have directly informed the direction of our quantum processor design. The second thing that you'll know is important is that as an electrical engineer, while I learned how to program in machine language and assembly code with a Motorola 68K series, not a lot of software developers program classical computers directly at the machine language. And what's important here is that when we released this Advantage2 prototype processor, we also updated our technology stack. We updated the visualizations in our problem visualizer, as well as our APIs and our cloud in terms of accepting the more largely connected problems coming in and solutions going back to make sure that you would be able to test them right away. And that's our commitment for each of the quantum processors that we will be releasing in the future, is that when they come online, we will also make the modifications to our technology stack to immediately allow them to contribute to the applications that you have built on this platform. Okay, let's look at what's next here. Okay, a gate model simulator and gate model programming in Ocean. So a lot of you know that late 2021, we announced that we were expanding our product series to include not only annealing, but also gate model quantum computing. And for those of you who are familiar with our annealing-based processors, you'll find that unlike quantum annealing, gate model quantum computing requires you to have some familiarity with quantum physics or the linear algebra over complex variables that you need to be able to program those systems. So by that I mean that the memory registers that you're working over are now representing complex variables, and you need to understand that. And when I say complex in this context, I mean the formal mathematical definition of a number that's represented with a real and imaginary part. In addition to that, the gates in gate model quantum computing are actually local Hamiltonians or unitary matrix transformations. And those are programming aspects that you need to understand as you're building up these systems. Now, we have built a set of tools in our Ocean SDK which provide you with a set of template gates that you can use to begin building up these circuits with a flexible content management environment as you're running these, as well as the simulator that you need in order to be able to resolve those circuits. Now, at this scale, this will actually allow a broad community of your team members to be able to understand the fundamentals of programming gate model systems. And it'll allow them to begin to understand the ground that we need to cover, not we just D-Wave, but the entire quantum computing industry needs to cover to get from these size systems to the commercial scale gate model systems that we need to be able to impact your commercial applications. And also, as they're working through this, you'll also be able to understand that really advanced algorithm design for gate model systems, for the foreseeable future, will be the domain of a much smaller, more specialized community of users. Now, I'm sure that many of you have Leap accounts. They've logged into our cloud, and you've begun programming our quantum systems. But for those of you who are new to this program, when you log into Leap, you're actually going to find that it's filled with resources, community forums, and support areas with documentation to help you begin to formulate your problems and approach business applications with quantum computing. Importantly, you're also going to find that you're going to get the authentication tokens that you need to access all of the power and the APIs to access all the powerful quantum and hybrid solvers that we have available in Leap. When you look at the quantum solvers that you have access to, you're actually going to find that there are 3 advantage performance update systems there, and those 3 systems are located in 3 different parts of the world. We have the system that's based out of Burnaby, Canada, in our office headquarters. We also have a system that we've installed in North Rhine-Westphalia in Germany at the Jülich Supercomputing Center. There's a system there, as well as the system in Marina del Rey, California. Those are our first European-based systems in Germany and our first US-based in-region system in California. And the benefit, I should also mention that these images here, these are not computer-generated graphics. These are actual photographs of the systems installed at those locations. And so if you happen to be at the Jülich Supercomputing Center, that's an area of their computing center that you can talk to them about and actually visit to see the system there, as well as for ISI. So the primary value of being able to have these systems globally expanded throughout the world is that you see quantum competence centers that and innovation centers that are building up in those areas. And people are really investing and pulling together broad sets of researchers and learners, giving them access to the systems and exposure to those quantum systems to begin programming, because there's a global drive in order to harness the power of quantum computing systems as effectively and quickly as possible, and to upskill the workforce and give them the skills so that they can come into our industries and begin programming these systems right on day one. The second thing is that as application development with quantum computing continues to mature, this is an important first physical step towards expanding the set of applications that we can look at to the set of applications where data sovereignty is an important consideration. So that's definitely an aspect of application development that a lot of governments are concerned with, the ability to maintain data sovereignty, and there is further to go in terms of developing those in the quantum cloud. But this is an important step that actually enables several other steps in that direction. All of these technological innovations over this past period since our last qubits, they have all worked together in order to support and enable the live enterprise application use cases that you've seen demonstrated on this stage today, and you'll continue to see demonstrated later today and tomorrow. And it's part of our continued commitment to make sure that we continue to increase the scale, the performance, but also importantly, the ease of use when it comes to building applications incorporating quantum computing technology. And it's never been easier to get started. When you log into Leap, you can get access to an integrated developer environment right in your browser. You can load application examples that we have built that are open source. So whether you're in a coffee shop or at home or in your office, you can begin programming a computer right now, and that's putting the power of quantum computing right into your laptops, wherever you happen to be. So I'm going to leave it on this slide in our launch program, which Mark talked about a little bit earlier, in terms of helping you accelerate your journey with quantum. And now I'm going to take off my presenter hat and put on my MC hat and invite my colleagues Mark and Emil back to the stage, and we're going to do a Q&A on the technology updates. Thanks, everyone.